Okay, translations, transformations, practice. So given the following graph of f at x, or for example, g at x, h at x, okay, apply each transformation to find the new function. Okay, so this is the original, this is f at x. Now f at x now maps onto what we call g at x, okay? So g at x equals this function that we have plus 1. So we're going to do this function that we have, and we're going up 1. So I'm going to label the main points. Those are like turnaround points. Okay, and I'm just going to move all of them up 1. Because we're given a graph, we can just do this graphically. We don't have to write it in a table of values. Okay, so graphically that goes up 1. H at x equals, so the function at x plus 2, this means left 2. I'm going to do a really bright color. So this point moves here, this point moves here, this point moves here, this point moves here, and this point moves here. A little confusing because of the horizontal lines, and we're moving just horizontally. Okay, but that's left 2. Okay, and then now what we're going to do is we're going to go right 1, and we're going to go down 4. Okay, because this is graphical, like a graph, I'm going to do this all in one shot. Okay, so right 1, 1, 2, 3, down 4, and plot. Right 1 and 1, 2, 3, 4, down and plot. Right 1 and 1, 2, 3, 4, 1, 2, 3, 4, and plot. Right 1, 1, 2, 3, 4, and then right 1, 1, 2, 3, 4. Now for each of the g at x, so these examples below, we're going to first identify the base function. So is it a line, a parabola, a root function, or a rational? Then we're going to describe the transformation in words. So I'm going to start A up here. So g at x equals x minus 4. So our base function is a line, y equals x, and the transformation is down 4. Okay, B, g at x equals root x plus 3. So our base graph, our base function is root x, and this means that we're going left 3. Okay, g at x equals x squared plus 7. Our base graph here is a parabola, y equals, or g at x equals x squared, and we're going up 7. Okay, for D, g at x equals 1 over x minus 5. So our base graph is 1 over x. You can put the restriction, x does not equal 0. And this means that we're going right 5. Okay, E, this is a parabola, y equals x squared. And this x plus 1 means that it went left 1. G at x equals 1 over x minus 6. So the base graph is 1 over x. And this negative 6 trails behind. It's not grouped with the x. So this is down 6. Okay, g at x equals root x minus 4. So our function is root x. And sorry, plus 2 at the end. So this is going right 4, up 2. Okay, and the last one, h, g at x equals 1 over x plus 7. So our base graph is 1 over x. This tells us that it goes left 7. And this tells us that it goes up 9. Okay, number 3, use words to describe the transformations that were applied to f at x. So f at x is the solid line here to obtain the graph of g at x, which is the dotted line. So this is f at x, and we're assuming that this goes on forever, and this is g at x. So for A, I'm going to write it down here because we're going to go on to number 4 as well. So the base function f at x is just root x. Okay, so what happened here is we went up 1, 2, 3. Okay, so we went up 3, and then we went to the right 2. Okay, that gives us the equation. Up 3 would be over here, right, trailing behind, and right 2 would be in the bracket with the x, but it would look like a negative. So we would have g at x equals root x minus 2 plus 3. Okay, so let's go from the solid to the dotted. So this is the parabola. Let's do this a little darker. There we go. Y equals x squared. Okay, this parabola, we're going to use the vertex as the reference point. 1, 2, 3, 4, 5, 6, down 6. So we'll write down 6. And then left 1, 2, 3, 4. Okay, so we have g at x equals x plus 4, because it's left 4, squared, down 6, minus 6. Okay, and then C. I'm going to use the vertical asymptote. So the vertical asymptote starts at x equals 0, and now the vertical asymptote is negative 4. So we know that this went left 4, sorry, the base function is 1 over x. Okay, we also are going to use this horizontal y equals 0, and it went down to y equals negative 2. So this is going to be down 2. So in other words, we're going to have g at x equals 1 over left 4 is x plus 4, down 2 is minus 2. Okay, 5a, write the equation for a parabola, so that's y equals x squared, that has been horizontally shifted 3 units right. Okay, so that's just y equals x minus 3 squared. Okay, B, write the equation for the reciprocal function. So the reciprocal function is 1 over x that has been vertically shifted 4 units down. So y equals 1 over x minus 4. Remember, the up-down like trails behind the function. Okay, write the equation of the square root function. So y equals root x that has been vertically shifted up 5 units. So we can put root x plus 5. Okay, D, we're dealing with a reciprocal function, which is y equals 1 over x, horizontally shifted 1 unit to the right. So that makes us go x minus 1 in the denominator, right? Because it's opposite of what it would look like. And shifted upward 7, plus 7. Okay, and then E, write the equation of the square root function. So we're dealing with y equals root x. So reflected in the y-axis, we're going to get to that, but I'm going to just do the, is actually negative x. Okay, and then has been vertically shifted up 3. Okay, so it's not even left, right. It's just up 3. So I can just leave negative x under the root and then up 3. And we're going to learn this portion in the next section.